In section 3, we're going to start looking at congruent triangles. So congruent triangles are triangles that are the same shape and size. So what that means is that each triangle has 3 sides and 3 angles. And if all 3 of the corresponding parts of the 2 triangles are congruent, then the triangles are congruent. So what that boils down to is the corresponding parts are the corresponding sides and the corresponding angles. So all corresponding sides have to be congruent and all corresponding angles have to be congruent. So if we look at our 2 triangles we're given, I can write a congruent statement saying the triangles are congruent. And I want to make sure corresponding sides match when I write this statement. So however I name my first triangle determines how I'm going to name my second triangle. So let's say I name my first triangle, triangle ABC. I say it is congruent, and when I name my second triangle, I gotta make sure corresponding angles and sides match up as well. So since angle A was congruent to angle E, I'm gonna start with that letter. Then angle B was congruent to angle F, and then angle C was congruent to angle G. So triangle ABC is congruent to triangle EFG. And if I happen to name my first triangle differently, then the naming of my second triangle would change as well. So the corresponding congruent angles, I already said that. So angle A is congruent to angle E. Angle B is congruent to angle F. And then lastly, angle C is congruent to angle G. So not only do the angles match up, but the congruent sides do as well. So I have AB, which means my side AB has to be congruent to side EF because of the ordering of the letters. And if I look in the picture, AB is congruent to EF. I then can say AC is congruent to EG. And if you look in the picture, AC is congruent to EG. And I can say BC is congruent to FG based on the ordering of my triangles when naming them, and in my picture, BC is congruent to FG. So when writing congruent statements for congruent triangles, the order you name your triangles is extremely important. Okay. So as I said, 2 triangles are congruent if and only if the corresponding parts are congruent. And this boils down to the statement corresponding parts of congruent triangles are congruent, which abbreviation is used as CPCTC. And we're going to use this abbreviation in proofs instead of writing out the entire statement. So each letter pretty much stands for a different part of the statement. So in our 2 figures, QR is 12, RS is 23, QS is 24, RT is 12, TV is 24, and RV is 23. We want to name the corresponding congruent angles and sides. Then we're going to name the congruent triangles. So let's first go ahead and label all of this. So QR has a length of 12, RS has a length of 23, QS has a length of 24, and then RT is 12, TV is 24, and then RV is 23. So labeling what you're given is helpful in naming your corresponding congruent angles and sides. So it's going to be easier to start with our congruent side since those were all the lengths we're given. We know that QR is congruent to RT. We know that RS is congruent to RV, and we know that QS is congruent to TV. Now we want to do corresponding angles. So we have angle Q is congruent to angle T. Obviously, angle R is going to be congruent to angle R. And lastly, angle S is congruent to angle V. So when I name the congruent triangles, start with the triangle on the left. I'm going to say triangle QRS is congruent to triangle, and because I had to write the corresponding angles, I can list it in the order I wrote them, T, R, and V. Since Q is congruent to T, R is congruent to itself, and S is congruent to V. We can also have properties of triangle congruence that we saw in previous sections. We have a reflexive, a symmetric, and a transitive property. So the reflexive property just says that a triangle is congruent to itself. So we have triangle JKL is congruent to triangle JKL. We have symmetric. So that would be if triangle JKL is congruent to triangle PQR, then we have triangle PQR is congruent to triangle JKL. So it doesn't matter which triangle you list first as long as the corresponding parts match up. And then there is a transitive property as well. So if triangle JKL is congruent to triangle PQR and triangle PQR is congruent to triangle XYZ, then triangle JKL is congruent to triangle XYZ. Again, these are statements we've used in the past with proofs, and they are applicable to triangles as well. So in our last example, we have triangle WXZ is congruent to triangle STJ. We want to name the congruent angles and congruent sides. And we don't have a picture, which we don't need, because the order that we name our triangles tells us the corresponding congruent angles and congruent sides. So I'm going to go based off the naming of the triangles, and then I'll draw a picture just so we can see as well. So angles. So I can say that angle W is congruent to angle S. Then we have angle X is congruent to angle T, and we have angle Z is congruent to angle J. And then for the sides, we have WX is congruent to ST, XZ is congruent to TJ, and WZ is congruent to SJ. And you can do this based solely on the order that you named the triangles. So let's go ahead and draw a picture so that you have an idea of what this looks like. And I'm not going to promise that these triangles look congruent because I am drawing them freehand, but let's just assume they are. So we have triangle WXZ and triangle STJ. And I've made sure to, when I named them, I start in the same place in both triangles. So then I know corresponding angles in each triangle have to be congruent. And then corresponding sides as well. And if I look at my two pictures and the way I listed out my corresponding angles and sides, my congruent statements match with the way I've labeled and drawn my picture. So let me know if you have any questions as you're completing the assignment.